metal motors. I just love them. Spent years trying to perfect ways of getting a gearbox to work. So there's a nice little gearbox that I've built. Really chuffed with that. I don't think I could make it any smaller. Absolute minimum size possible. Problem is, as soon as I built those, these came along. They are quite brilliant and only cost just over £1 from China, maybe more now. When I bought them they were about that sort of price. So my problem today is how to control them. I know I can switch them with a switch. Wow, bit violent, needs fastening somehow, but I can control them with a switch. But I want to be able to press a button and for it to start. So the logical way is to use a transistor. A BC517 Darlington pair is my favourite. So I've connected it up here. Now I want to be able to run on 3 volts. I want to use lithium cells, and lithium cells at minimum should be about 3 volts. So my idea is that I should be able to set up a circuit to run on 3 volts. There are a lot of problems with that, not least of which is that a lot of chips won't run on 3 volts. And since I've got a lithium cell, I want to be able to go down to 3 volts. I could of course use a power bank. A power bank would work, but that's taking it up to more than 3 volts, only to bring it back down again, which doesn't seem sensible. If I were using a microprocessor, then yeah, maybe that would be a good idea. But I'm not. I'm using just a straightforward, simple circuit. So that's what I've set up here on the breadboard. Essentially, I've got a 3 volts coming in and 0 volts along the bottom. I've put an ammeter here going from the capacitor down to the 0 volts, so I can measure here the current through the capacitor. The capacitor then is a 100 microfarad capacitor. It connects to a button which joins to a resistor, and that in turn comes down through a 1 mega ohm variable resistor. So here we have ammeter, capacitor. Oh, it's a 10 ohm resistor to the switch. I'm not too sure if that's okay, because it's still going to charge the capacitor very fast, but at least it's better than nothing. 1 meg coming down to ground, and then a 47k going into the base of my Darlington transistor, which connects to positive via a diode. So here we have, what do we have? Difficult to see, but there's my Darlington transistor, the BC517. The diode is underneath this wire here, and then coming across here, that green wire goes to my motor, and over here, connected to positive through this meter, I have the other side of the motor. So I can measure the current into the motor here, the current through the capacitor over here, the input voltage up here, and here I'm measuring the voltage across my Darlington to see what the voltage is when this is on. So let's try it. Can we see the motor? Let's swap the motor round so I can see it. Not doing very well there. I got a good view of my coffee cup, but nothing of the motor. Is that better? It's going to catch on the wire, innit? Let's try it. So there, my motor's turning, and I can take readings. Let's try it again. I note that my power supply is not too good. It goes right down to 2.88. Over here we've got the voltage across the transistor from the collector to the emitter, and if I try again, you can see that that is about 0.8 of a volt, going up to 0.9, 1 volt as the capacitor discharges. Down here then, the current through the motor, as it is there, is something like about 210, 200, 190, zapping down, so about a maximum of 240 when I first press the button. I could alter the 1 meg variable resistor and get it to run for longer, but I just want to try it as it is. Over here we're measuring the current through the capacitor, so if I try that again, then that is in microamps, so I've got about 12, 11, 10, 9 as it goes down and discharges goes down, so we're talking microamps through the capacitor. The worrying thing is the 0.8 volts across the transistor. If I've only got 3 volts to start with and I'm losing 0.8 across here, then that means I'm only getting 2.2 volts through my motor. Would be nicer if I could get more volts through the motor. And I believe I can do that using one of these things, which is a FET, a field effect transistor. Now this particular one is a sort of oddball in as much as general description. It's an N-channel trench MOS transistor, and it's a logic level FET. Logic level is important because logic level means it will switch down at less than or around 5 volts, and I need it to switch at 3 volts, of course. So this then is the PHP 69N03LT N-channel FET. The beauty of it is this graph here, which shows me that down at now what does it show me? Well, these different lines are different voltages between the gate and the source, and I'm going to be down here somewhere at 2 volts, or maybe 3, but somewhere down here about 2 volts, and at 2 volts then it looks like I can get about an amp out of drain source. I'm using 3 volts, which is massively up here, but it ain't going to make much difference. It's going to be about an amp it can pass, which is very good. Of course, if I were using a gate source of about 4 volts, then I'm up at about 50 amps with this thing. It's absolutely fantastic. So let's try that then. Take this out. Bye bye Darlington pair. And let's input. Can I? Should of course have switched it off before I put that on. So there, I now have my FET, exactly the same position, but now I get 0 volts on here. I get about 250 milliamps through my motor. My capacitor is still got quite a bit, and it still knocks my power supply down, but yes, it's a lot better current through the motor than with my Darlington. and I think the time on is longer as well. So that is brilliant, but it's a big thing. It can handle 50 volts. I don't want 50 volts, I'm only using 250 milliamps. So what would be nice if I could find a FET in the same what? Pin out or package, same package as my Darlington transistor. But I can't find one. I've looked and looked and I can't find one. But what I can find, or at least I can't find at the moment, oh yes I can, it's there, is this. This then is an AO3400 N-channel enhanced mode field effect transistor. If we look at its curve, that's this one, the AO3400, we find that it's got 5 amps output. Once again we're looking round here at our V gate source of 2 volts. We could get 4 amps out for a 3 volt DS, drain to source. For 3 volts drain to source, I could easily get 5 amps out. Now this is horrendous because this thing is a minute little surface mounted device. A bit too small for me to handle. So what I've done is to mount it onto a piece of strip board. So can we see the thing? That's it there. It has its drain coming down here onto this leg. I think it's its gate coming down onto the middle leg, and then I've just bridged across the top down onto the source leg here, and I've cut underneath the track that goes vertically there, cut underneath that, so the gate and source are separate. Real tragedy that I can't find one is a TO92 package. I've looked at various TO92 components, and well, I could find a 2 N730s, but down at 3 volts gate to source, minimum of 3 volts, then I've got about 100 milliamps, if that. Plainly not enough for what I want to use. I've looked at others like the BC517. I've tried that one. It'll work on 3 volts, only just though. Needs to be 4 volts to be able to get my 250 milliamps through. And the other one is the BC517. That didn't work either. I haven't got one, but it don't look like it'll work. And then there's another one here, all of which need 2 higher gate voltage, gate to source voltage. So let's try with my little surface mounted gizmo, and if I put that in, it's in the wrong one, but it shouldn't matter. And there we're going. 250, 260 milliamps here, 0 amps from the drain to the source, that's across it, 0.39 down here. The motor's dragging my power supply down again, but it seems to work well. So there we have it, but it does slow down, but it definitely works on 3 volts and would do what I want it to do. Brilliant. So where do I go to from there? Yeah, right. Where I go to from there is I build one. On a little bit of strip board, I build myself one of these circuits. So here it is. I've left this bit of strip board on. I could have cut it off there because it doesn't go sort of past only goes up to here where I have my 2 output pins. I have 2 pins here for my switch, which go then through. I've actually used a 100 ohm resistor here into my capacitor. Largest I've got is 33, which is surface mounted, so that's 33 microfarad. I have my positive in here and my negative in there. Problem was, as usual, nothing ever works right. Always need to try things out, and I designed a circuit for it. There's my circuit to go on my strip board. So we have the 0 volts coming in, plus comes across, comes to my switch, comes to my diode. From the diode we have the drain, which would go out to the motor out here. I have my chip here. That then comes to my, well, it isn't 47, 33 microfarad, I didn't have a 47, to my variable resistor, and the centre leg. That top leg isn't connected. I've put a cut in there. Although if I had done that, it'd be wrong, wouldn't it? It isn't like that. That top leg isn't connected, but that does connect across there. Let's rub that out and try again. So let's have a look again now what's happening. The top leg of my variable resistor isn't connected. It's a break in the track to the switch, which is there, which then goes through the 100 ohm down and charges up the capacitor. The gate of my FET then is connected to there, the source connected to 0 volts, and the 0 volts has a cut here, so it doesn't connect to the line of the variable resistor, it just comes down. Brilliant, I thought, absolutely brilliant. When I built it, it doesn't work because I'm looking from the top and the transistor is the other way around, so this is the source and this is the gate. What to do? Well, I thought, I'll be naughty. I've done it before. And what I've done is to just put the transistor on upside down. Can we see that? Probably not. Is it going to? Is it going to? Not good. Anyway, we're there. So where's my transistor? My transistor's here, and because its legs are so, well, it's so small in height, I've managed to solder it upside down, which makes a lot easier circuit. So does it work? Well, let's try it and see. It probably won't. Let's see if we can find a motor. Take this one off here. Oops, no I won't. I'll take this motor off here. Never worked out which way round to make connectors. This I think is probably the wrong way round because I've got power on the male and I think it should be the other way, but never mind. There's my motor connected on. I then need my lithium cell, get it the right way around. Hope that's on, and then press the button, which I haven't got, so I'll be naughty and just connect those two together. And hey presto, my motor is turning, which amazes me. It'd be nice if it weren't making so much noise. And there it is, it's finished. So that could be my finished delay circuit. I'd need to put a button on, of course, but move that off, and there it goes. Brilliant. Absolutely, oh, I'm over the moon with that. Can't say how chuffed I am. Anyway, onward. Let's see where we can go from here. I think I'll have a go at building one using a 555 timer. Really old-fashioned stuff, but, well, let's go for it. Bye.